There's a lot of free and open source programs that can compete with the commercial software. FreeCAD is not one of them. Modeling a part in FreeCAD isn't just trying to get the geometry in there, you're also trying to evade a horde of bugs, some of which are big enough to star in a kaiju movie. Still, FreeCAD has two things going for it. One, it's free even for commercial use. Kramer Power Electronics has zero software budget, so free is good. Two, it's not OpenSCAD. OpenSCAD is basically writing a program to create a part. It's perfect if you were able to look at the matrix and see blondes, brunettes, and redheads in the code. But if you need a 3D CAD program with no budget, need it to work something like commercial parametric CAD programs, it's pretty much FreeCAD or nothing. Here, you can follow along as I try to use FreeCAD to create a model of this 1964 Dodge Dart headlight rim. The goal with this model is to have something that you can print with a resin printer or laser-sintered nylon, so I can't just make a single block and use a slicer to give it 20% infill. It has to be modeled as a shell with support ribs. The model is more complicated than it looks. At first glance, it looks like you could use a solid of revolution tool to make the outside and then drill holes, but the inside's offset from the outside diameter, and it's angled at the top. So you've got some rather complicated geometry to deal with. Now, if this were a normal tutorial, I'd show you the correct way to use the software to get something done. I'm calling this one an anti-tutorial. I'm going to go through the process of trying to approach this in ways that would get the model done if you're using a commercial CAD program like Inventor, SolidWorks, Fusion 360, or Libre Design. You'll see what happens when I run into those kaiju-sized bugs. The video doesn't always show going back to fixed dimensions or some of the other tweaks I made to the final model, so it won't quite get you the final result if you follow this video. I had to edit it for time a lot because this represents a couple hours of CAD work. So if you're considering FreeCAD, you can decide if this sort of frustration is worth the price. If you're starting to use FreeCAD, it'll show you how to dodge some of the bugs. If you're one of the coders who maintains FreeCAD, I hope you'll use this to get you to debug some of those issues I've run into. If you're one of those free and open source advocates out there claiming FreeCAD is on equal footing with the other CAD programs, well, I hope this video is going to convince you to stop saying that. Whether you're making a model with FreeCAD, you'll want to save your work often. If you run into these bugs, either go back to a previous save or save a new branch of the file. One problem I've run into is sometimes using the undo command or deleting the feature that seems to be causing a problem doesn't always fix the problem. If you save it over a good file, you've lost a lot of work. So, when I modeled this, my first attempt was to create a solid model and then use the thickness tool to convert this to a thin outside shell. Inventor calls this a shell tool. It works great for this if you need the part to be, because if you need to change how thick the part is, you can just edit what you did with the shell tool to change the total thickness instead of having to edit a bunch of parts. In Inventor, you could also reference a dimension on the first drawing and all the other sketches, and you could go back and edit the dimension and change it, but it doesn't work that way in FreeCAD. However, there's some critical differences between the shell tool that you'd be using in Inventor or SolidWorks and the thickness tool in FreeCAD. The biggest one is that the shell tool actually works and the thickness tool doesn't. I've never really been able to get the thickness tool to give me anything but an error message. So the next attempt, I tried to create two thin wall solids of revolution and join them together. But I ran into another FreeCAD limitation. It requires a part body to be one contiguous shape. You can't model a portion of the part here and a portion of the part there, then model what connects them like you can in a commercial CAD package. When you model a new section, the first one disappears. It's still sort of possible to grab the two portions and use an additive loss tool to connect the parts, but something breaks. It just doesn't connect the two sections together correctly. So if we can't model it as two thin-walled sections and connect them, the next thing I tried to do is go back to my solid model and use subtractive tools to remove parts of it to make my own shell. First I tried the groove tool that subtracts a solid of revolution. Well, it's supposed to. That's not what it really did. Then I tried to use the pocket tool. This should cut off a circular section above the center line. but that's not working on this model either. On to the fourth attempt. This one uses thin sections and keeps the part as one single solid piece the whole way through. First, I create a solid of revolution to make the outside edge. Since I'm going to be using subtractive tools to clear out the center, this is a good time to make stiffening ribs. I'm going to use the tab tool to make the first rib. Then I use the polar pattern tool to make 30 copies that fill 360 degrees. It takes FreeCAD a while to render, but it doesn't break anything. Next step is to model the inside portion. Instead of just modeling the first ring, I'm going to use FreeCAD's additive cylinder tool and extend it all the way through the bottom of the outside rim. Then I create a subtractive cylinder to snip off the part extending below the surface. Now I need to create the part where it flares out between the inside and outside portions. There's two steps here. First, a 45-degree flare, followed by a sweep that I'll use the additive loft tool for. To get the 45-degree flare, I'll attach a work plane to the top of the model, then move it down 5/8 of an inch, draw a circle on that work plane and use the tab tool to extend it out with a 45-degree taper. To do the sweep, I'll need a way to grab the end of that 45-degree taper to put a sketch on it. Can't just turn the bottom invisible and reveal a nice flat plane. So instead I'll need to use the pocket tool to hollow out the top. I create a second pocket to cut through the flared section. I have a flared section I can grab to draw the top sketch for an additive loft. Now that we've got an additive loft connecting the two, we can do a subtractive loft through the center of the additive loft. And now we've got the overall shape of the headlight rim. There's one step left. Drill a pattern of 3 bolt holes to hold it to the car. These are going to need to be simple, flat holes. You can use the hole tool, but it's not really worth the effort if you aren't doing countersunk or threaded holes. Just do a sketch of the 3 bolt holes, make a circular pattern, and then use the pocket tool to cut through them to the flared section. And we're done.